She had, you know what the purpose of an umbilical cord is, right?
Yeah, I do.
Okay.
And I'm pretty sure
I think I'll shut the computer at 4:30.
No.
Okay, well, you gotta wait 10 minutes to go ask the teacher, I guess.
That was like sixth grade. Not even sixth grade. Fourth.
Okay.
That's my one friend.
No, I'm saying like I got different outfits. I only got shorts outfits though.
He was literally me and him were like absolute.
Cause when I bought my clothes, I thought it was
We were the
decent
Zoomers of the
I
entire
bought most of
school.
my outfits with shorts. I can wear most of them.
We were the ones constantly getting in trouble.
I don't go see my shorts.
And he was a redhead too, so he was probably stealing his soul.
All right, ladies and gentlemen, today we got some activities to do, but first, let's take out your computer. Let's get logged in and let's take a look at that worksheet we were looking at yesterday so that we can review a little bit of gas laws, ladies and gentlemen. What?
I wasn't here yesterday, so we're going over answers.
Well, I'm going to show you how to do more of it because it's not due till the end of the day today anyway. So, the answer keys are online if you need to check them too. All right. Okay. All right, so today we're going to be able to look at the different gas laws, and actually you're going to see all of them in action today, ladies and gentlemen, with the activity we have set up for you in the back of the room. So, we're going to, again, in this unit, look at predicting what will happen to the variables of a gas if we change them. So yesterday we started looking at the worksheet for Unit 6, and also on that worksheet, ladies and gentlemen, we summarized all of the different gas laws that we had. So this is the worksheet that we are talking about, ladies and gentlemen. This one that says Conceptual Chemistry Unit 6 Gas Law Worksheet. Today we're going to do problem number 9. We did some others yesterday, but today we're going to do number 9. But before we do that, ladies and gentlemen, all right, there were 4 gas laws that we gave you, and then there was a 5th one that kind of combined them, ladies and gentlemen. So the first gas law that we gave you yesterday, or in this unit, was what was called Boyle's Law. What were the 2 variables in Boyle's Law? What were the 2 things that were changing? Pressure and volume. Now, I'm sorry, thank you. Now, that also means that what was held constant in Boyle's Law?
Temperature.
And?
Volume.
Nope, not volume.
Oh, sorry, pressure. Gas.
Temperature and amount of gas. Because remember, we need to account for all 4 variables. Pressure, temperature, volume, amount of gas. If 2 of them are changing, 2 of them are held constant. What kind of relationship was Boyle's Law? It was an inverse relationship. It was an inverse relationship. If one variable increased, the other decreased. That is what it means to be inverse. Then, ladies and gentlemen, we did our second gas law, and that gas law was called Charles' Law. Charles' Law dealt with 2 different variables about gases. What were they? Volume and temperature. Those happen to be in what kind of relationship? Those were in a direct relationship. Okay? Then we got into our third gas law, ladies and gentlemen, and that was a gas law called Gay-Lussac's. Gay-Lussac's law related what 2 variables?
Pressure and temperature.
Pressure and temperature. What kind of relationship? Direct. Please remember, in a direct relationship, ladies and gentlemen, if one variable goes up, the other goes up. Or in a direct relationship, it is possible that if one variable goes down, the other one will go down. In a direct relationship, they go in the same direction. That is the main thing. Questions? All right, there was a 4th gas law that we gave you, and that was called Avogadro's. law. Now, Avogadro worked with what two variables?
Volume
And or amount of gas. What kind of relationship? Direct. Okay. Now, this is critically important for what you are going to do on your test. It is also important for what you are going to do on your lab today. So does anyone have any questions on any of these? Okay. Just to point out a couple of other things, ladies and gentlemen. If we were to look at a graph of Boyle's law, what would the line be doing? What direction would the line be going in Boyle's law if it is an inverse relationship?
down.
If it is an inverse relationship, it means your line is going to be going down. Now, what it also means is that the two variables, pressure and volume, mathematically, we are going to do what to them? We are going to multiply them. All of those things indicate an inverse relationship. If you happen to look at a graph and the graph is going down, that means whatever is on the x and y axis are in an inverse relationship. If you were to see a formula for the variables and they were multiplied together, that would tell us that it is in an inverse relationship. So all of those things go together, ladies and gentlemen. Now, these three are all direct afterwards. So if we were talking about a direct relationship, what would a graph look like? Up. Straight would mean a constant. And you're right, most of these are constant. But to be a direct relationship, the line goes up. That is the main thing. What do we do with our variables? Mathematically, we divide them. So that means V divided by T. That means P divided by T. And that means V divided by N. Okay? Now, in these gas laws, because there are only two variables, if I do something to one, the other has to go in a certain direction. Because there's only two things that are changing. So therefore, if I decrease the pressure, the volume must
Increase.
If I decrease the volume, the temperature must. I said decrease the volume, temperature must decrease. If I decrease the pressure, temperature must decrease. And if I decrease the volume, the amount of gas decreases. Now, we could also say if we change this one, if this one goes up, this one has to go up. If this one goes up, this one has to go up. If this one goes up, this one has to go up. Those are all direct relationships. If this one goes up, this one has to go down. It all depends on which one you happen to be changing, which one you happen to be controlling, okay? But when you do something to one of these, the other has to react. Questions? Okay, then we got into a gas law that was called combined gas laws. Now, in combined gas law, ladies and gentlemen, the only thing that needs to be held constant is the amount of gas. So that means that P and V and T are all changing. All three of them. Now, I can't show you what a graph of this looks like. Why? Because some of the relationships in here are direct. P and T, direct. V and T, direct. However, P and V are in inverse relationship still. Now, normally, if pressure were to go up, what would volume have to do? Go down. But because I am not holding temperature constant anymore, it is possible that pressure could go up in a problem and volume could as well. Well, no, that means we still have to figure out what would happen to T. But what I'm saying is people will be like, well, Mr. Brand, how can pressure go up and volume go up if Boyle's law says one goes up and one goes down? Boyle's law only applies if these are the only two things changing. If I am changing the variables, I can change two of these variables in a way they normally wouldn't go. Okay? So I could increase the volume and I could decrease the temperature because I am controlling those things. I'm not letting Charles' law take control. Because there's the third thing that I'm changing or can change, these things don't have to do what they're supposed to do over here. They only do this when only two things change. Questions? We're good? So what that means is you're right. Now, here, when it comes time to make a prediction, we might be able to say something goes up. We might be able to say something goes down, but we may also not be able to tell. Why? Okay, but why couldn't we tell? What happens in there that says, oh, you can't figure this out to make a prediction? Anybody remember? Okay, so let's go to here. Okay, so let's say we are solving for pressure. Okay, if the volume goes down, what would that tell pressure to do? Go up. If the temperature goes down, what would that tell pressure to do? Go down. So now which one happens? How do you know? What? Okay, but this is the one that we're looking for, right? And I agree with you. Most of them are going down. But because this one is going down, that tells this it's got to go up. Because this one is going down, this one tells it it's got to go down. So which one of these wins? That's when we can't tell. That's when we can't tell. If these two variables are telling this one to go in different directions, we cannot tell. Okay? We cannot make a prediction anymore. Now it comes down to you would have to do the math. Now it comes down to, come on. You would have to do the math, ladies and gentlemen. Okay? So, with these, ladies and gentlemen, you get three possible answers in combined gas laws. It goes up. It goes down. Or you cannot tell. In this one, we can't tell. We can't tell because one is saying go up and one is saying go down. We have no way of knowing which one is going to win unless we actually do the math. And we're not going to do that. Questions? All right. So now let's take a look at this problem, ladies and gentlemen. When you do this problem, here is my suggestion to you. Number one, read through it. A gas has a pressure of 1.32 atmospheres, a volume of 3.65 liters, and a temperature of 45.3 degrees Celsius. If the temperature is raised to 80.3 degrees Celsius and the volume is changed to 2.54 liters, what will happen to pressure? Assume no change in the amount of gas. Okay, first of all, last 5 words of the entire thing, not including the parentheses, is telling you to solve for what? Pressure. Pressure. That is what I'm going to be solving for here. That is what I am looking to find. What is going to happen to the pressure? Now, here was the pressure originally. There are 3 things that can happen to it. What are they?
Up, down, stay the same.
Up, down, stay the same. We're going to see if we can figure out which one happens. Again, I've identified what this is. This is a pressure. 3.65 liters and 2.54 liters have to be the same unit because they have this, or have to be the same type of measurement because they have the same unit. So must 45.3 degrees Celsius and 80.3 degrees Celsius. Now, let's figure out what type of measurements these are. All right, the liters is what type of measurement? Volume. The degrees Celsius is what kind of measurement? Temperature. And the 1.32 atmospheres is?
Yes.
Yes. Wait, no, that ATM, that's pressure.
That's pressure. So the first question, how is the volume changing in this question? Well, volume is here and here. What is it doing?
It's going down.
It's decreasing. Okay? So if volume goes down, what effect would that have on pressure? What would that make pressure do if volume goes down? Pressure is going to increase. That is Boyle's law. Okay? How is the temperature changing in this question? What is temperature doing? Temperature is increasing. Now, what will that cause pressure to do if temperature increases? What? What?
Decrease.
What?
Decrease.
What?
Increase.
Thank you. Increase.
Sitting there like, what? Yeah,
I was hoping you would change your mind.
well, no, I'm not gonna change my mind just because you're yelling.
No, change it because you're wrong. It's going to increase. These are in a direct relationship. So again, if the temperature goes up, so will the pressure. So what are both variables telling pressure to do here?
Increase.
So what does pressure have to do? It has to increase. There is no other choice that it has. It has to increase based on here and here. These are both telling it to increase. It has to increase. Okay. So how were you able to determine that? How were you able to determine that pressure was going to increase?
Boyle's law.
Nope.
What?
Nope. It's part Boyle's law. That's true. But instead, just tell me, why do we say pressure has to increase here? What's temperature making it do?
It's adding thermal energy.
Okay, you're going way too complicated for a simple person like me.
It's making an increase.
What? I am totally agreeing with everything you're saying. I'm just looking for a more simpler answer. What does temperature cause pressure to do if it increases?
Increase.
Causes it to increase. What does volume cause pressure to do if it decreases? So what are both variables telling pressure to do?
Increase.
So why does it increase?
Both the variables.
Because both variables are telling it to. Both variables say to go up. That's why it increases. Both variables are pushing it in the same direction. Okay? Now, what if one was saying going up and one was saying going down? You can't tell. Why? Because one variable is trying to increase and one is trying to decrease. So that is what I am looking for you to do in there. Questions? All right.
Concern.
Let's do one more, ladies and gentlemen. It's not on your worksheet, but this was an older worksheet that I used to do with my classes. So let's take a look at it. Again, I hope so because I have the hot plates on.
Oh. I was just making sure because I'm like, what is that noise?
Okay. A gas at 30 degrees Celsius has a volume of 0.995 liters when under a pressure of 736 millimeters of mercury. What pressure is needed for the same gas sample to occupy 1.25 liters at 50 degrees Celsius? Okay, I've highlighted my temperatures. All right, what are my pressures here? Well, what is my one pressure then?
Oh, there we go. Okay, sorry. It's the MMHD.
Okay, so this is a pressure. I don't have a second one, right?
No.
It's what I'm solving for.
I was looking.
Not a problem. That's the point. You're not going to find a second one if it's the one you're solving for. So then I should be able to find two volumes. What are they?
The 2 liters of what is it? 0.995 and then the 1.2.
Okay, now this is a little different table than we were just working with. But which one are we solving for? Pressure, volume, or temperature? Okay, what? Which one? Pressure. So the way I would have asked people to have done this worksheet a while back, ladies and gentlemen, was I asked you to simply highlight the one that we were solving for. Which of these three? We're solving for pressure.
Did you give this out like on printed?
Yes.
Oh, okay.
Okay. So what is happening to volume in this particular problem? What is volume doing? Increasing. So volume, we know what the change is. It's going up, correct? What would that cause pressure to do? Go up or down? If volume goes up, what happens to pressure?
Goes down.
Goes down. So that's what would have happened according to the volume. Now, temperature must also be changing. What is temperature doing? Going up or down? It's going up. So what would temperature cause pressure to do if it goes up? Okay. So in this problem, based on what you're seeing here, what would our prediction for pressure be? Would it go up? Would it go down? Or can't you tell? Why?
You can't tell.
Why not?
Because they're going like one.
Because-
to do one thing. And the
Thank
other
you.
telling it to do
Because
another
one is
thing.
saying go up,
Because temperature.
one is saying go down. You can't tell.
There's temperature in both, and they're both saying different things.
Okay? So, all right. What gas law did we use here? Yeah.
Yay.
That's what combined gas law is about, ladies and gentlemen. It's about using the other gas laws to possibly be able to predict what would happen.
I kind of like this one.
If our variables are going in opposite directions, we can't do anything about that.
Why did you stop giving this one out?
Because I had to print it and I just tried to make it different and better and on that other one. And so,
I like that
I
one's
like
better.
it.
what?
I like that one's better.
Okay, next year I'll switch back to this
Because
one.
of the arrows.
You
Yeah,
like
I
the
like
arrows?
it. I
You
like
like
it.
coloring, basically? That's what you're saying?
Yeah,
Okay.
it makes it fun. If you make it fun,
No,
people will want
the
to
arrows
do
just
more.
make it so
Well,
you can
I
see.
hate making things fun because then people want to take my class and stuff. Okay, ladies and gentlemen. Anyway, questions?
No.
Okay, let's see how you do with understanding these. Here's what is going to happen, ladies and gentlemen. We are going to put you into the lab in a minute. Now, I will tell you this. You are not using combined gas law today. You are not. You are using one of these four gas laws. And you are only using one of these four. What I mean by that is, in none of the demonstrations that you are going to do is the amount of gas and pressure going to change, because we have no gas law that involves pressure and amount of gas. Okay? We have no gas law that involves temperature and amount of gas. So each one of the stations you go to will either involve pressure and volume and temp, pressure and temp, or volume and amount of gas. You have to figure out which one is which at which station. So, ladies and gentlemen, if you would, go to Google Classroom, and open up the gas law mini lab that is sitting there waiting for you, either in Google Classroom, ladies and gentlemen, in the classwork, or on the stream, but please open it up. And it looks like this. So here's what's going to happen. You are going to study the effects of gas laws by changing variables in various demonstrations and seeing how other variables react to those changes. So in the lab, you will literally change something. Pressure, temperature, volume, or amount of gas. You will change one of those four things. Something else will change because of that. And only one other thing. And because of that, you're going to be able to figure out which gas law you're using, and you are going to be able to tell me what is happening. Okay? Now, the gas laws involve a change in two of these four variables: pressure, temperature, volume, and amount of gas. And if amount of gas is involved, the only other thing that could change is volume, because we don't have a gas law for anything other than that. If pressure changes, it might be volume, or it might be temperature that is also changing, because we have a gas law for each one of those. In the activity, you are going to identify the independent variable, the thing that you changed about the gas. It's all about gases. What did you change about the gas in the container? Did you change its pressure? Did you change its temperature? Did you change its volume? Did you change its amount of gas? Which one did you actually change? And then how did you change it? Did you increase it or decrease it? Then you're going to identify what the dependent variable was. What changed because of the change that you made? And how did it go? Did it go up or did it go down? Now, I want you to understand this, ladies and gentlemen. You are not breaking any laws today. If you're telling me that you have increased the temperature, what has to happen to the volume if you're using Charles' law? It got to go up. You can't tell me this is going up and this is going down, because now you're breaking a gas law. You cannot tell me that if this increases, this also increases. If that's the case, it couldn't have been these two variables. It had to be something else, because pressure and volume will never both increase if they are the only things that you are changing. Okay? Never. Okay. Then finally, ladies and gentlemen, you're going to tell me what kind of relationship it is. Well, if both of these are increasing, what kind of relationship? It is a direct. If one is increasing and one is decreasing, it's an inverse. And then you're going to tell me which gas law you are using. Which gas law you are using. So, here you go, ladies and gentlemen. We have 4 stations. Station number 1 is one that is a little bit difficult to set up. So please listen, please watch, and please know what you're doing. Now, there are 4 stations set up to do station 1. The 2 lab stations on this side are both set up to do station number 1. The 2 lab stations at the back are both set up to do station number 2. The 2 stations over on this side are both set up to do station number 3. And the one in the middle is set up to do station number 4. So that means there can be 4 groups working at any station at any time. You shouldn't be fighting over equipment at all. Here's what happens in station 1. There is a little, what is called a tea light candle. There is a dish with 3 coins. Set the candle on top of the 3 coins. You are then going to, ladies and gentlemen, take your water and fill this almost full. Okay? Now, the reason the candle is on there, ladies and gentlemen, on the coins is so that it doesn't float away. It's sitting on top of the water. You will then light the candle. You will take a beaker like this. You will put it over the candle and you will observe what happens. Something is going to change. Matter of fact, 2 things are. One of them you changed. One of them changed because of that. So that's the first one. Now, you are going to make observations for what happened in here. Okay? In here, you're going to make observations for what happened. Okay? Sorry. No. In my copy, another teacher put all the answers in. I don't want you to see them.
What a silly teacher.
Well. Okay, sorry. Okay. So again, ladies and gentlemen, after you tell me what happened, after you tell me your observations, then you're going to go down to the table. And at the table, ladies and gentlemen, you are going to tell me what variable you controlled and what happened to it. You're then going to tell me what other variable changed and what happened to it. Looking at these two will tell you if it is an inverse or a direct relationship. Looking at these two will tell you which gas law it was. Now again, remember, we only got 4 gas laws. You can't tell me the 2 things that aren't a gas law were changing and going, because that isn't what happens in this activity. Okay? So that is the first one you do. When you're done, you take the top off, set it on the side, take the candle out of here, take this over to a sink, dump it. Leave it sitting there for the next group to use. Questions? Station 2, there is a flask with a balloon on it. There is a container of water sitting on a hot plate, and there is a container of ice water sitting back there. You are going to take the balloon and the flask, and you are going to put it in the hot water bath and let it sit in there for a minute or so. You are going to observe what happens to the gas inside the balloon. Then, ladies and gentlemen, you're going to take it out of the hot water bath and you are going to put it into the ice water bath. And again, you are going to observe what happens to the gas inside the balloon. Write that down. Now, please listen carefully. When you get down to here, what variable were you controlling? Now, I do realize that you heated it and then cooled it. Pick one. Tell me the change either when you increased the temp or decreased. And then tell me how the other variable reacted when you did that one. You don't put increased and decreased here. Pick one, either when you put it into the hot water or when you put it into the cold water. I don't care. But then tell me what happened to the balloon when you did that. Okay? And then again, here, what kind of relationship? Here, what gas law? Station 3, ladies and gentlemen. You are going to take a syringe. Take the cover off of it. You are going to take the bottom, the thing out of it, the syringe apart. You put this in, you put your syringe back in, and you set it to 30. And then you put your cover back on. If you try to take the syringe apart without taking the cover off, you will not get it. Take the cover off, put the marshmallow in here. Now you are going to take the syringe and you are going to back it out, and you are going to push it in, and you are going to see what happens to the marshmallow inside when you do each. What happened to the marshmallow when you pulled the syringe out or towards you? What happened when you pushed the syringe in or away from you? Then you're going to fill out this table. What did you change? Did you increase it or decrease? Now, again, I know you're pulling this out. That is one change. You're pushing it in. That is the opposite. Pick one of those two changes and describe what happened to the other variable at that same time. Okay? Questions? If you put down on here increased and decreased, and then you put in here increased and decreased, I'm marking it wrong. Okay? Questions? All right. Your last station, ladies and gentlemen, and you do not have to do these in the order they are. You can do them in whatever order you wish. This is called a fizz stopper. People buy these and they put these on bottles of soda, 2-liter bottles of soda, before they put them into their fridge. Okay? Inside the bottle, there is a thermometer. This is a thermometer like would be inside of a fish tank. Now, this thermometer reads in Fahrenheit and Celsius. Which one do we do in this class?
Celsius.
So that is the one that is on the left. Now, the way this thermometer works is it lights up 1 or 2 temperatures. If it lights up 1, it's telling you that it is at that temperature. If it lights up 2, it is telling you it is in between those 2 temperatures. So, for example, this is now showing green and blue. Green is 22, blue is 20. That means this is at 21. Okay? You are going to take and you are going to tightly put on the fizz stopper, and you are going to pump it about 45 to 50 times. And you're going to see what happens to the temperature inside there, but you're also going to notice what happens to the bottle before you pump it up and after you pump it up. Okay? So this one, there is a spot where you are going to put in the, before you pump it, what the temperature is and what the bottle feels like. After you pump it, what it looks like, or what the temperature is and what it feels like. And then also, when you finally go and you remove this and you take this off, if you notice anything then, any observations when it was removed, you write them down here. And now again, ladies and gentlemen, you go to that box on the bottom. What did you control? How did you change it? What changed because of that? How did you change it? Direct or inverse? What law? You have got a half an hour to get 4 stations done. Should be easily able to get them done. The matches are at the stations. Please put them in the can when you are finished with them. The metal can. If you put water into anything into here, please dump it in the sink. Don't dump it back into the containers. Go to work. By the way, marshmallows, when you're done, throw them out. Throw them out. Do not have someone else use them. Go to work, ladies and gentlemen. Go. Go, 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 go. I wouldn't. Who's your partner?
Ken, right? Yeah.
Okay, then let them know and then go. All right, let's go, ladies and gentlemen. But Kevin, you gonna take a break or are you gonna go get some work done?